Here's a tutorial to walk through some of the oxygroups paper and the acid naming paper. Okay, you don't have to memorize this box, you just have to know how to use it. It's also on your ion chart, but I put it at the top here so you didn't have to flip quite so many papers. There is a basic, most common kind of an oxygroup, and that's going to end with 8, like chlorate here. One more oxygen than 8 is per whatever 8, so perchlorate. One fewer oxygen is going to be chlorite. Notice it went one more oxygen, one fewer oxygens, and two fewer oxygens is going to be hypo whatever-ite, so hypochlorite. Remember, there's an invisible one there. The charges don't change, so that's pretty easy. Hypo means under, by the way, like hypodermic needle, under skin needle. So, hey, let's do this one. Phosphate. They tell you it's phosphate. Also, you would know that if you looked this up, that phosphate is PO4 minus 3. You could look that up there. One more oxygen would be perphosphate then. So PO4 minus 3 is per phosphate. And one fewer, and one fewer than that. One fewer would be phosphite. And one fewer than that would be hypophosphite. And once you know how to do those, you can come down to here. So what we're going to do is make our plus minus pairs. And remember, the charges always have to add to 0. So potassium is what? May not seem like it, but potassium is K, and it's in my +1 column. So K, and note to self, it's +1. Iodite. Well, I don't know what iodite is, right, but I bet its cousin is on your ion chart, otherwise it's not a fair question. And iodate is here. I had iodite, yep. Iodite then would be one fewer oxygens than iodate. So not IO3, but IO2 minus 1. The charges have to add to 0, but this time they already do, so we'll leave them alone. If you want to erase the charges, that's fine, because officially they're not really part of the answer. They're just our notes to ourselves, but if you don't want to erase them, don't. All right, how about calcium nitrate? Calcium is over here. Keep looking until you find it. It's in our +2 column. Nitrate is going to be a group, you know, because it ends in 8. And since it ends in 8, it's going to be on our list. Nitrate is NO3 minus 1. But the charges have to add to 0, and they don't yet. So what we're going to do is we're going to have 2 of the whole group here, and you have to put parentheses, and that means I have 2 of the whole group, because if you do something like this, I have to mark it off a little bit. You can't do that, because that looks like 32 oxygens and 1 nitrogen, and that is not what we meant. We meant 2 of that whole group called nitrate. And now I have 2 minus 1s and 1 plus 2, and that does add to 0. We'll do one that's another step up in difficulty here. The Roman 3 means the charge is +3, and iron is from the Latin, so it doesn't work in English with the symbol. It's Fe, which would make more sense if you speak Latin or Spanish, but it's Fe, and they're saying, hey, it's the +3 kind. And what is sulfite? Well, its cousin would be on your chart, otherwise it's not a fair question. Sulfate is here, it's SO4 minus 2. And sulfite would be one fewer oxygen than sulfate, so SO3 minus 2. Now, what we have here is +3 and -2, and here's the thing I drew before. If you have +3 and -2 and the answer must be 0, how many of each do you need? Well, they're going to meet at +6 and -6, aren't they? So how many -2s do you need? This is a multiplier. I need 3 of them. And how many plus 3s do you need? That's a multiplier. You need 2 of them. So we're going to have 2 of this and 3 of that, because that is 3 sets of minus 2 is minus 6, and 2 sets of positive 3 is positive 6, and now the charges add to 0. It's a little bit more difficult, honestly, going the other way. We're going to give the name, and if needed, we're going to put the Roman numeral in the name. So what is Al? Keep looking. I know it's hard to find them sometimes, but it's aluminum. And aluminum is in our plus 3 column, so do we have to tell the reader that it's positive 3, or should they be able to figure it out? No, if they even went through, year 1 chem, they should be able to look at a periodic table and say, oh yeah, it's positive 3, so I'm not going to put the Roman 3. They should be able to figure that out. It's a little too obvious to bother stating. So what is SO3? Well, of course, you may not be able to remember yet, but its cousin is probably on your ion chart. Look, its cousin is SO4 is minus 2, and that's sulfate. And you had SO3, so 1 fewer oxygen, and sulfate would be sulfite. We don't need to put anything about the charge in the name because they should be able to figure this out. Sulfite is always SO3 minus 2. So we don't have to say what the charge is. They should be able to figure that out. How about barium and phosphate? Now, barium is over here. It's in my plus 2 column. So they should be able to figure out that it's plus 2. We don't have to put a Roman 2. And what's PO4? It's not super obvious, but you do have this chart. PO4 minus 3 is phosphate. So phosphate, and that really should be good enough for your reader to figure out the formula from that, because that's always a plus 2, they can look it up. And that's always PO4 minus 3, they can look it up. So let's go to one where they can't just look up everything. Let's go to 30. CO is cobalt. Now remember, down in this area here, the charges are not obvious, and I'm not pointing an aluminum. I do include aluminum in the plus 3, but from here, off the stairs and down here, the charges are a big mishmash, and it's not obvious at all, and I never figured out a pattern. So if it's down there, take a look on your chart. Do we have cobalt on our list of charges? We do, except there are 3 kinds of cobalt. So when we write out cobalt, it is not enough to just put the name. We are going to have to tell the people what the charge is. And I know you probably didn't figure it out yet, but let's put parentheses just to hold a place here. And what's it attached to? ClO2, okay? Well, is its cousin on your chart? You bet it is. It's ClO3 minus 1 is chlorate. And you had ClO2, which is 1 fewer oxygen than chlorate. So it must be called chlorite. Now, this was a minus 1. And the charges must add to 0. Here's our dividing line. This is the minus side. That's the plus side. I had 4 sets of minus 1. And the answer must be 0 in the end. So what's the charge of cobalt? It must be positive 4. So we're going to put a Roman numeral 4 in there and tell them, hey, it's the plus 4 type. How about 32? Ni is nickel, and nickel is here. It's down in that unknown zone where the charges are not obvious. So we're going to look up, is there more than one charge on nickel? Yes, there is. There's 2, plus 2 and plus 4. Okay, so we will have to tell the people what the charge is, because even if they look it up, it's not obvious. So how about we put parentheses as a placeholder there? And what's PO3? Well, its cousin is here. PO4 is phosphate, so PO3 must be phosphite because it's one fewer oxygens than phosphate. So that must be phosphite. All right, and what was it charged? -3? Okay. Now, the plus minus pairs must add to 0, and you had 2 sets of -3. The minus side must be -6 then. If the charges must add to 0, then the left side must be +6 total, and it took 3 nickel atoms to do it. So it took 3 things. It's hard to make 3 with 2 hands, isn't it? It took 3 nickel atoms, to do it, and the answer is +6. So what is the charge of the individual atoms of nickel? It must be +2. And we're going to put a Roman 2 there, and that is, hey, this is the +2 version of nickel. I'm going to do acids now. And you're going to need some real paper switching. You're going to need your acid naming box here, and your naming notes here, and your chart up here. So we're going to refer to this a lot. So one thing I would put on the bottom, I probably should have typed it in, but you can write it in, is hydro-blank-ic acid uses only one element on H. So I would write that out. Hit pause, write that out. So let's do an example here. Look, one element on H. So it's hydro. We said something. Well, that's chlorine, isn't it? So it's hydrochloric acid. And what is an acid? Acids give H+. So if they give H+, they must have H+. So notice all our formulas start with H, because there must be an H, and H is a positive, and positives go on the left. So where's another one with one element? Just Br. We said it's hydro something ic acid. So this is hydrobromic acid, because that's bromine. Here's just one element, and that's sulfur. And with sulfur and phosphorus, the R sound comes back. So it's hydrosulfuric acid. And 2 more examples, real quick, would be, this is just iodine, so it's hydroiodic acid. And this is just fluorine, so it's hydrofluoric acid. After that, we've got to use that naming box. And let's do this one. What is attached to the H? That's the key. PO4. Well, what's that? PO4 is phosphate. And here's the new info here. Look at your acid naming box. If you're using something 8, then you have something ic acid. So if you're using phosphate, you're using phosphoric acid. You make phosphoric acid. Remember I said the R sound comes back for phosphorus and sulfur? So it's phosphoric acid. Which leads us to PO3, and that's one fewer oxygens, isn't it? So one fewer oxygen than phosphate. Then phosphate would mean it's phosphite. And then we switch boxes, and if you're using phosphite to make an acid, you have something as acid. So phosphite makes phosphorus acid, OUS, phosphorus acid. How about we do 11? What's SO5? Well, I bet its cousin is on our chart. SO4, 2 minuses on our chart, and that's sulfate. And we have one more oxygen than sulfate, don't we? We have SO5, so that must be per sulfate that we're using. And if you're using per sulfate, you are making an acid that is called then per sulfuric acid. The other little tricky one is this one. that is acetate. I know it doesn't look the same, and in fact I kind of meant to change it, but this is really the same formula, just kind of more spread out. This is the same thing as that. If you go add them up, yeah, it is. And that is called acetate. And if you're using an 8 ion, you get ic acid, so acetate ion makes acetic acid. And I know the pronunciation changes a little bit, but that's the way everybody says it. Let's try some of these. Hydroiodic. Remember, hydro was a clue for just one element. So iodic means it's iodine, and I don't expect yet that you remember where iodine is on the periodic table, but we'll search for it, and it's over here. And it's important at this point when we're building the formula to make a note of the charge. It's -1. I is -1. So I is -1. And then remember, H's give off H+. So they have H+, and the charges must add to 0 because that's what nature does. So basically we're going to throw a bunch of H's at it. And how many H pluses do you think will stick to one negative? And the answer is 1, because that already makes the charges add to 0. So there's your answer. Remember, the charges aren't officially in the answer, but I don't want to argue about it too much. But 24 was HI. So the easy ones are the hydro ones. How about this one, hydrofluoric? We said it's just one element, and fluorine is in my -1 column. And again, we're going to get pretty much a repeat here. How many H pluses would stick to that? 1. And I know that's a repeat. People have told me. Oh, sorry, that's not the repeat. That's the repeat. As a matter of fact, why don't we do this one? 26. Hypoiodous acid. You're going to need your acid naming box. Hypo something as acid would be using hypo something ite. So hypoiodous acid would be using hypoiodite. But what the heck is that? Well, I bet its cousin is in that chart up there, though. And what was it? Two fewer. What is hypoiodite? Hypoiodite would be 2 fewer oxygens than iodate. 2 fewer oxygens than iodate. What is iodate? It's here. So if iodate is IO3 -1, and we're looking for 2 fewer oxygens than iodate, we have IO1 -1. And you can put the 1 if you want. People don't. I mean, we didn't put it here, we didn't put it there, we didn't put it there, did we? When you leave a blank, it's 1. And the point of an acid is that it has H pluses, so throw some H's at it, so to speak, and of course 1 H plus is what would stick to a group that is -1. And how about we do one more, phosphoric acid. So phosphoric acid would come from using phosphate, and phosphate is there, and it's PO4 -3. PO4 -3, and then how many H pluses would stick to that? It is 3 of them, isn't it?